Okay, we're going to move on with more probability. And again, it's just probability of an event is just kind of the number of chances to win or for the event to happen over the total number of chances. That's probability. We'll talk about odds in this video as well. So say you have a spinner, and so, you know, like 1, 2, 3, 4. Your probability of, say, landing on a 2 is there's only one chance, and they're equal out of 4. And again, you could divide or turn it into 8%, okay? If it looks like this, maybe 1, 2, maybe this is a 3, and then maybe we cut this in half. Maybe there's another 1 and a 4, okay? Here, that's a 1, sorry. That's a 1 and that's 1. Okay, so here my probability of 2, getting a 2, is still 1 out of 4. But notice my probability of, say, getting a 4, I would have to cut these into equal pieces to compare. So my probability of getting a 4 is 1 out of 8. Notice my probability of getting a 1, that's a 1, is 1, 2, 3 sectors out of 8, okay? So, you know, sometimes you have to kind of look at equal things. Sometimes if you have a couple different things going on, if there's 2 events going on, it's more complex, then you kind of have to make a tree diagram or list it out. So for example, maybe I have a spinner with A, B, C, D, okay? So it looks like that. And then maybe you're going to draw a card that either has a 1, 2, or 3. So first you're going to spin, and then you're going to draw a card. You know, obviously these are hidden, and you're going to grab it. So then I'm going to ask you a question. Now, this is more complex because 2 things are going on. So you have to think of your options. So you have A, B, C, D is the first thing that could happen. And then make a tree diagram. You could get a 1, 2, or 3, 1, 2, or 3, 1, 2, or 3, 1, 2, or 3. Okay. And so if I say, what is the probability of you getting an A and a 3? Well, A with 3 is right here. That's 1 chance out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would be your probability of getting a 1 or an A and a 3. Okay. So again, if, you know, if it's more complex, you're going to have to list it out. Say you roll a die twice, or maybe 2 different die, whatever, it doesn't really matter. That's not easy because easy is only rolling 1 die. Okay, so if you roll 1 die, you could get a 1, 2, 3, 4, 5, 6. But if you get 2, you could get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 2, 4, 2, 5, 2, 6, 3, 1. I'm going to just get these done all the way. 6, 1. 3, 2, 3, 3, 3. So this is called the sample space, and it's kind of a pain if you have a complex event to list it all out. Not super fun, but necessary because it's not easy probability. So you can't just look at it and tell. If there's more than one thing going on, this is what you do. So you can kind of see the math, so to speak. And notice you should not be surprised that there are 36 outcomes because think of the multiplication principle. You have 6 choices for the first die, and you can have repetition. So you can have 6 choices for the second die. There are 36 possibilities when you roll. Those aren't very good, but when you roll 2 die, okay? All right, so I could ask you a question here. I could say, what's the probability that you get a sum of, say, 6, okay? So you look at your chart, this adds up to 6, 6, 6, 6, or 6. So there's 1, 2, 3, 4, 5 chances out of 36 that I get a 6. If I do the not, kind of like when we did sets, like remember when we did not A, you know, so the probability that the sum is not 6 would be the rest of that. What is that? 31 out of 36, okay? Ors can be a little tricky, and is not so bad. Say, what's the probability that I roll a, let's say a 2 and a 4. Now be careful. 2 and a 4 happens here, but 2 and 4 also happens here because I'm rolling a 4 and a 2 here and here. So I have 2 chances out of 36, which is 1 out of 18. And again, you could do okay, I remade my chart just because it got a little messy and I wanted to talk about this problem. So ORs, you have to be a little careful. The sum of 7, so 7s are in this diagonal, those all add up to 7. So the probability of getting a 7 is 1, 2, 3, 4, 5, 6. Okay, there's 6 of them out of 36. But the problem is I also want to know, or I roll a 3. Well, let's see, I roll a 3 here, and I roll a 3 here. And also my 7s are this diagonal. All right, so if I just add up the numbers, I'm going to be double counting too many things. So if I add up 1, 2, 3, 4, 5, 6, I'm like, okay, 6 out of 36 are these guys. Rolling a 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The problem is you've double counted some things. So like, for example, this guy counted in the 7 and as a 3. This guy counted as a 7 and a 3, and you double counted this 3, 3. So you would have to subtract 3 out of 36 to fix your answer. So what is that? 18, is that 15 out of 36? So you might, let's just count without doing the double counting. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and I can get that same answer. So ORs, you got to be careful because, yeah, there might be some double counting involved, and that would be a problem. All right, let's talk about odds for a second. Odds are not probability, okay? Odds are part to part. So it's kind of more of a ratio of good to bad, yes to no, win, don't win. All right, so say your probability, say we have like some marbles again. So say we have red, red, and green. So your probability of getting red is you have 2 chances to win out of 3 total, okay? So if you think of a little, I don't know, strip diagram, you have 2 chances to red, red, and you have this green over here. And so you can see your 2 out of 3 total chances. Excuse me. But you can also see part to part. You have 2 chances of red for every 1 green. That's odds. Odds is when you compare red to not red, basically. Okay. All right. So say I have, let's do a spinner here. Okay. So say I have a spinner with 1, 2, 3, and 4. Okay. Your probability of landing on a 1 is 1 out of 4 because you have 1 chance out of 4. That's your probability. Okay. Your odds, well, if you think about it, you have 1 chance to land there, right? And then you have these other guys, 2, 3, 4. You have these chances to land over here. So you have 1 chance to win, and you have 3 chances to lose. This is winning. This is losing. That's odds, okay? So if someone says, you know, like, what are your odds of getting sick or getting the flu or something like that? Okay, if your odds are, say, 3 to 119 of getting the flu, this is you getting the flu. This is you not getting the flu. There's no total in odds. This is like, if I make my little strip thing, you have 3 chances to get sick. You have 119 to not get sick. So if you want the probability of getting sick, you have 3 chances to get sick, but you need the total, which would be, what would that be? 122, okay, would be your getting your probability. Okay, so you just kind of make sure, you know, you kind of understand those and can kind of know the difference that probability is part out of the total. Odds are, you know, yes to no. And in horse racing, they actually do losing to winning. So if you have like 7 to 2, this is the chance to lose, this is chance to win. So again, if I think of this, I have 7 chances to win, or sorry, no way, lose, and I only have 2 chances to win. That's my odds, but my probability of winning, probability to win, is I only have 2 chances to win out of 9 total, okay? So my probability. So in horse racing, they always put the losing to winning ratio. So losing to winning. So my probability of winning would be that 2 chance out of the total of 9. So odds are a little weird. All right, I'm going to talk about expected value. Okay, so we'll just start expected value. And expected value is kind of looks like this. It's probability times value plus probability times value plus probability times value, and you keep going, okay? So if I had like, say that you're going to have 3 kids, and I want to know the expected value, and we're going to focus on having girls. Okay. And just something with a 50-50 chance. We could do flipping a coin head and tails. I'm just trying to make it easy. So we could do either one. You know, so if you prefer heads and tails, we could just flipping to heads. Doesn't matter. We just want something that has a 50-50 here to make life easy. So we can do heads. So we can have the probability of 3 heads if you want. All right. So if we're going to do that, again, this is a complex thing. We're not just doing one thing. We're flipping a coin 3 times. So we have heads or tails is the first flip. The next one could be heads or tails again. The next one could be heads or tails again. Heads, tails, heads, tails. Okay, and we're going to make a chart of all the possibilities. So let's see. Before we do that, this is heads, 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 tails. This just helps me list them out. Heads, tails, heads. Heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tail, tail, tails. Okay, so I'm going to make a chart, and we're focusing on probability of what? I said heads. Okay, so we're going to focus on probability of, you know, getting heads. And our value in this case is the options, right? So I'm going to just make some. We could have 0 heads, 1, 2, or 3. We can't have 4, obviously. We're only flipping the coin 3 times. All right, so what's the probability of getting 0 heads? Well, it looks like that happened when we had tail, tails, tails. So there's 1 chance out of 8, okay, because there's 8 total here. Probability of getting 1 heads is, let's see, where did we have 1 heads? 1 right here, and 1 right there. And do we have another one? Right there. So 3 out of 8. Chances of having 2 heads, let's see, there's 2 heads here, 2 heads here. So is that right? So we get what? 2 out of 8? Is that okay? Are we missing any? Did I get that guy? Maybe not. I think I missed him. 3 out of 8. That should be better. All right, we'll check it at the end. And then getting all heads would be that guy. Okay, so do these add up? These should add up to 100%. So 1, 4, let's see, 6, 7, 8. Yeah, we're good. Okay. So what the formula says is you take your probability times value, probability value, add it up. And I like to write my charts this way because what we're going to do is we're going to take probability times value, that answer, plus probability times value, put plus probability value, and then we're going to add all of those up. So you're going to take 0 times that, you're going to get a 0. We're going to take 3/8 times 1, we're going to get that. Here we're going to get, what is that, 6/8, but again, you could use a calculator. And then let's see, what's this last one? We're going to get 3/8, and we're going to, you know, you can use a calculator, that's fine. So this is going to be 9, 10, 11, 12 eighths. And I'm going to reduce that. But again, you do not have to do fractions. 3 halves. If you use a calculator and do decimals, just don't round them, like use them all. This is going to be 1.5. And that should make sense. That is your expected value. You would expect, if you flip a coin 3 times, to have 1.5 heads on average. This is kind of like an average. So what you're like, but Julie, that's impossible. Well, yeah, but if you do this 200 times, right? You flip a coin 200 times. Sometimes you get heads, heads, tails, you know, tails, tails, heads, maybe heads, tails, tails. You're going to have 200 things. When you count the number of times that you get, you know, heads and you average it out over all 200 times, on average, you're going to get 1.5 heads. Will you sometimes get 3? Yep. Will you sometimes get 1 and 1? Yep. Will you sometimes get none? Absolutely. But on average, this is what you're looking at. Okay. All right. I'll do some other examples with this. I'll make a video just on expected value, but that's kind of the start of it. Excuse me.